Good morning, everyone. Today we have topic understanding categorical data. The purpose of this topic to understand how we can categorize the data because there are so many forms of data. It could be contextual data, it could be numerical or any kind of data. So at the time the analyze the data must be in proper nature or proper form. So categorization is required in certain point where the requirement vary. So understanding this topic or understanding categorical data is more important part of data analytic labs. So we are just going through this topic. Starting from the first point, that is the dealing with categorical data. In this, we need to create a categorical data set. For doing this, we need to create an object that is PD and via importing library that is pandas. So import pandas as PD is the first point for the coding purpose we need to do. And the second word we need to define the data frame. So df is a variable by which we are defining the data frame, and we are just putting some information like green, red, blue. These are the colors of the any t-shirt size, and so and so ml xl, these are the size. And with respect to we have the price, and we have the class. So you can see into the output, there are so many things is showing by the output. 0 1 2 3 0 1 2 3 0 1 2 3 in the column side we represent the column index, while a row side it is represented the row index value. So no column name is defined so far, only the data frame is just containing the information in rows and columns nature. So if we are using a df dot column, so output will be a range index start 0, stop 4, step 1. So columns name will not be shown by this syntax because column names has not been defined so far. So for doing this, we need to define the column names. So what are the column names? We are using a syntax, very simple syntax, that is df dot columns is equal to color, size, price, and class label. After printing the df, of course, assigning the column names, so output will be displayed in the simple manner as shown by the slide in easy manner. You can see over the slide as well. So now color, price, size, and class level are the column name by showing or define the data frame. Now with the help of the df dot columns, defining the column names. Previously it was not defined, so now with the syntax we can define the column name, so which is required part. Next we have ordinal feature mapping. For doing this, what we need to do in order for our learning algorithm to interpret the ordinal feature correctly, we should convert the categorical string values into the integer. However, since there is no convenient functions that can automatically derive the correct order of the labels for our size feature, so we have to define the mapping manually. So for doing this, we have the syntaxes into the next slide. Let's see. Now continue from the previous slide, that is ordinal feature mapping. So here we are just implementing ordinal feature mapping concept. So let's assume that we know the difference between the features, such as xl is equal to l plus 1 is equal to m plus 2. So size mapping is a variable by which we are just making a dictionary and assigning the numerical value to the string value. xl, l, m are the string value and which are used by the 3 2 1 respectively. It means we are using the integer value for its size. So df size, we are just using the column name, and with the help of the data frame variable, so we are just mapping such size with the help of the map function. With the help of the map function we are doing such activity. Now after printing df, assigning the size, so you can see over the slide the output is shown by the size column. MLXL is not showing or displaying by over here. It is showing by the 1 2 3 or 3 to 1 respectively, when we assign the XL, L or M value respectively. So this string value has been converted into the integer form. So this is known as the ordinal feature mapping. It means we are mapping such features with the help of the order we are defining by the user. So as a user we are defining the order, so this feature is known as the ordinal feature mapping. So string mapping dot items with just function item function by which we are just saying what are the values which is occupied by the dictionary. So dictionary item xl3 l2 m1 is showing by the item method. So this is a simple output. So over the slide you can see entire thing and as well as the code. If we want to transform the integer value back to the original string representation, so we can simply define a reverse mapping dictionary. So here the variable we are using inverse size mapping variable that can be used to pandas library uh, with the help of the map method. So in the map method which is stored in the pandas library, so we are using the map method. So on the transform feature column similar to the size mapping dictionary as we have declared or defined the previous slide that is used in the previously. Inverse size mapping is a variable in which we are just making a dictionary by which we are just following the loop. So v is a value and key is represented by the k. So in this we are just using a loop for the grabbing or grasping the information. So for k comma b in the size mapping dot item. So from the item method, the information which is stored or represented by the item method and which is just picking up the values on key and inversely assigned to the v into the v and k, it means into the value and key. So here this loop is just assigning the inverse values to the key and key to the values. So after printing the you can see the 3 colon xl 2 colon l and 1 colon m is showing. So it is clearly defined that the inverse part we have just done completely, and through the next part it is just showing that with the map method we are just passing the variable that inverse size mapping. So with the help of the map method the size will be completely changed into the uh, previous mode. It means the size is just values represented by the 1 2 3, so it is just transform into the mlxl as we have seen in the previous slide as well. So this is just idea about the inverse size mapping, and it is also possible to, and this is done by the ordinal feature mapping process. So this is the example of the ordinal feature mapping where the features are mapped or in the order nature we can do. So inversely also we can do, and simple we can do. So this is this idea about the ordinal feature mapping. Now we have the class levels encoding. So in this usually class levels are required to encode it as integer values, while most estimator for classification in scikit-learn libraries convert class levels to integers internally as a good practice. We may want to provide class levels as integer arrays to avoid any issues. And here the few points we have over here. To encode the class levels, we can use an approach similar to the mapping of ordinal feature as we have seen into the previous slide. So discuss in the previous section. Next, we just have the point. Since class levels are not ordinals, it does not matter which integer number we assign to particular string level. So we can simply enumerate the class level starting at the zero. So this is just idea or definition of the class level encoding. And in the coming slide or next slide, we will see how we can do class level encoding. For doing class level encoding, just we need to starting from the first point, that is np.unique df class level. So in the class level we have the various class values, class 1, class 2. So uniqueness we need to identify. So uniquely we can identify there are two type of the class 1 and class 2. So as output shown by the our slide, that is array class 1 class 2 and data will be object of course. And next we have the class mapping variable by which we are just using labels and index values, and we are just assigning some values through the loop part, so making a dictionary part and followed by the some passing values in through the np.unique df class level. So here we are using the enumerated function. So this is the method enumerated function, so by which the uh, it just keep the information class 1 class 2, and enumerated of a method just represent there the class 1 class 2 is just assign some value as in form of the index. So a class 1 assign the value 0, and while class 2 assign the value 1. default automatically. So it's just starting from the zero automatically. So user is not required to assign any value like ordinal feature mapping. So in the class encoding variable or class level encoding, with the class is any things which is assigned by enumerated methods automatically is starting from the zero. So as you can see over the output, class 0 and class is assigned the one level. And now we want to mapping dictionary transform the class level into the integer. Of course we can do. So class level is the or column name we have over here. So with the help of the map method and passing the variable class mapping, so we can assign the assign the class level actual class level in form of the string to number. So as you can see into the output, class level column is just having the values, not the string form. It is just having the form in the form of the integer value. So class level change into the 0 1 0. 0 means the class 1 and 1 means the class 2. So this is a simple output code we have seen over here, how we can change or how we can use the class level encoding scheme. Like ordinal feature mapping inverse process, we have over here the inverse class mapping process. So it is also possible to have inverse class mapping into the original class mapping. So it is also possible through the simple example we have seen to the ordinal feature mapping as well. And so we have also over the codes here. So class level is changed into the 0 1 0 into the class 1 class 2 class 1 here. So this is a simple output and a code over here as we can see. Now we have a third category of the data formation. So we have the over here the nominal feature encoding. So far we have used a simple dictionary mapping approach to convert the ordinal size feature into integer, because sklearn library is estimator that treats class levels without any order. So we use the convenient level encoder class to encode the string level into the integer. So we can use a similar approach to transform the nominal color columns to our dataset as well. So far we have seen ordinal feature mapping and class level encoding scheme. Ordinal feature mapping, user has to define the order, so this is known as the ordinal feature mapping. But in case of class level encoding, class labels are converted into the numerical and vice versa also possible too. So this is done by the enumerated method. So enumerated method is assigning the default values from the starting class, that is the 0, to how many classes we have. So till the number of classes we have, 0 and 1 2 3 4 5 6 7 so on. So enumerator just starting from the default value 0. While in case of nominal feature encoding, the features are assigning string to numbers or integer, but randomly assign the order. So it is not end of the, it is not up to the user end. So it is done by automatically some process and through the class which is known as the class which is known as the class level encoder process. So the level encoder is a class by which we can do this thing. For doing a nominal feature mapping, we have the simple idea. The x is a variable which is just having the data frame columns called color, size, and price. So with the help of the values variable, we are using such information into the x variable, and just after printing the x, what we have the, just all the information. So you can see over the slide, we are not using the class level columns over here. So now we have to import some libraries. So from the sklearn library, a preprocessor class, we need to import class level encoder class. So class level encoder is a variable which is just using a class level method. This is method by which we are just creating object which is known as the color level encoder. So with the help of this object, because variable itself, okay, class variable is also known as the object. So with the help of this object, we can transform our information which is stored into the x. X is what? X is our newly defined data frame informative variable. So all the variables we need to pick. So we are just x colon comma 0. So there is no step is required to jump. So all the rows and columns will be included over here, which is defined by the x. And just after the printing of all the information, you can easily see the 120 ml excel 10.1 13.5 15.3. So it is okay for the ML Excel 10.1, 13.5, 15. Because all the information are showing by the same. But in case of the color, the green, red, blue, these color are changed into the some numerical value which are using a 1 to 0. So these are the values which are using by the level encoder scheme method over here. So this is known as nominal feature mapping. So this is a simple example over here, the nominal feature mapping. We may want to create a new dummy feature for each unique value in the nominal feature column. In other words, we would convert the color feature into three new features: blue, green, and red. So binary values can then be used to indicate the particular colors of the sample. For example, a blue sample can be encoded as a blue is equal to 1, and green is equal to 0, and red is equal to 0. So this technique is called one hot encoding scheme. In order to perform this transform, we have to use a learn preprocessor one hot encoder library. So for doing or applying a one hot encoding scheme, we have to do same process over here. For applying level encoder or one hot encoding scheme, starting from the first point, that is a class level encoder is equal to level encoder. So here we are just creating an object that is a color level encoder is object by which we just need to fit and transform our all the information which are stored into the x variable as we have seen to the previous slide. So the output will be shown by the 120, 123, 10.1, 13.5, 15.3. So all the features are changed or transformed into the integer values. So size also changed into the string to numbers or integer form. Same color has been also be changed into the string to numbers. So this is good things from the more analytical work. So for the doing or apply the one hot encoder scheme, what we need to do, we need to import one hot encoder class from the executed library in form of the preprocessor. So one hot encoder is equal to one hot encoder categorical feature we need to go for, which is n equal to 0. What is the 0 we are passing? We are just pass the column index value. So what is the column index value of the color? That is 0. So we are just passing the categorical feature on the basis of the color. So we need to pass the categorical feature is equal to 0 in from bracket. So we are just passing about the color index value, so that is 0. And after printing the one hot encoder, the output will be shown by like this one, as you can see over the slide. The most syntax we have over here, that is the one hot encoder dot fit transform x dot to array. It means we are using variable one hot encoder is an object by which we are transform fit and transform our data information which is stored into the x variable and convert into the to array. So as you can see into the output, 0 1 0 1 10.1 and respectively we have all the information. So 0 1 0 means we are talking about the green color is has one value, rest of the color has the 0 value, and rest of the information like size uh, values and price value are same, but we are talking about the color. So color values represent to the three different form. So 0 0 1 means we are talking about the red color has the value 1, rest of the color has the value 0. And 100 means the blue color has the value 1, rest of the color has the 0. So this part we have already discussed to the previous slide about this color, blue color. So this is the things which is categorized into the such forms. So color is categorized into the various forms. This is done by the one hot encoder process. And if I talk about the very simple meaning statement, I'm just remembering, in case you need to label encoder before this one hot encoder to convert the categories into integers, then you can use the one hot encoder directly. So this is the point we have to keep in mind. So this is the simple output we have seen. Or we have a simple alternate method. So we have the get dummy method by which we can decide or divide all the information into the form of uh, subcategory or category nature. So PD is the object of the pandas library, and with the help of the get dummy methods we can just pass all the information: price, comma, colors, comma, size. So colors automatically divided into the various part of double category. So output would be like as shown by the PPT. Price value will be price, that is 10.1, 13.5 and 15.3, while size will be the 1, 2, 3. But if we talk about the color, so color will be categorized automatically through the get dummy methods. So the color value will be the 0, 1, 0, 0, 0, 1 and 1, 0, 0. So it is done by automatically. So no one had hot encoder and label encoder is required over. So with the help of only the get dummy method we can do this thing. So today we have seen the various categorical data formation approach, like ordinal feature mapping, nominal feature mapping, and if we talk about the label encoder class, so we have just seen this part, and most important part we have seen the one hot encoder. So with the help of the one hot encoder we can define the any column into the various subcategory nature to represent what kind of information we have in form of the 0 and 1 form, and different approaches we have seen. So this is just idea about the color category categorization. So the example, the color categorization was the best example. So this is the over or idea about the from my side. Thank you all.